Hello friends, welcome to London Dispersion Forces. So the learning objectives of this video are understanding London dispersion forces, its formation, significance of London dispersion forces and examples. So friends, what are London dispersion forces? By definition, the weakest forces between the opposite ends of the temporary dipoles are called London dispersion forces or dipole-induced dipole forces. So what are temporary dipoles? Dipoles for a short period of time are called temporary dipoles. These are of two types: instantaneous dipole and induced dipoles. So the force of attraction between the temporary, instantaneous and induced dipoles are called London dispersion forces or dipole-induced dipole forces. Example is that of helium, neon, argon, chlorine and methane. Significance of London dispersion forces. Friends, London dispersion forces are present in both polar and non-polar molecules but are most significant in non-polar molecules and monoatomic molecules. Why? These are more significant in non-polar and monoatomic molecules. The reason is that there is no other force present in non-polar and monoatomic molecules. Therefore, London dispersion forces are significant there. Temporary dipole formation. Friends, look at here in a diagram the first atom having symmetrical distribution of electrons. And a time comes when these electrons move towards the one side of the atom, whereas the nucleus move towards another side. As a result, temporary dipoles are formed by the unsymmetrical distribution of electrons. Remember that this dipole formation is for very short period of time, and as a result of this dipole formation, partial positive and the partial negative poles will produced. So friends, when the temporary dipole come closer to a symmetrical atom, its electron cloud repel the electron cloud of the symmetrical atom, and as a result a dipole is induced in it. This dipole is called induced dipole. Therefore friends, London dispersion forces are also known as dipole-induced dipole forces. Now let's discuss the factors affecting the strength of dipole-induced dipole forces. These are number of electrons in an atom or molecule, size of an atom or molecule, and the surface area. So friends, what will be the effect of the number of electrons on the London dispersion forces? So, greater the number of electrons, stronger will be the London dispersion forces. So friends, which one of these having the strong London dispersion forces? Iodine or fluorine? Now look at here, the number of electrons in iodine are 53, whereas the number of electrons in fluorine are 9. So, what will be the effect on London dispersion forces? We know that greater the number of electrons, stronger will be the London dispersion forces. It means that iodine having stronger London dispersion forces as compared to the fluorine because of the greater number of electrons in iodine. So friends, what will be the effect of the size of atom or molecule on the strength of London dispersion forces? So, greater is the size of a molecule means the number of electron must be greater, which result in greater chances of polarity, and as a result, there will be a stronger London dispersion forces. Now friends, consider here two atoms, hydrogen and the carbon. Look at the electronic configuration of hydrogen, that is 1s1, means that the hydrogen having one electron in its orbit, whereas look at here that the carbon having an electronic configuration of 1s2, 2s2 and 2p2, means that it having two electrons in the first shell and in a second shell it having four electrons. Now look at here, due to greater number of electrons, the size of the carbon is greater as compared to the hydrogen atom. And we have already discussed that as the size of an atom or molecule increases, which is due to the greater number of electrons, which result in greater chances of London dispersion forces. So here the carbon having stronger London dispersion forces as compared to the hydrogen. Now friends, let us discuss that how the surface area of an atom or molecule affect the strength of the London dispersion forces. Now friends, look at here carefully that if the surface area of an atom or molecule is greater, means that it having more contact points, which result in a greater chances of polarity, and as a result the London dispersion forces will be greater. To understand it clearly, let us take a comparison of pentane and a neopentane. Both the pentane and a neopentane having a same molecular formula, that is C5H12, means that both having 5 carbons and 12 hydrogens. But how it will affect the London dispersion forces? So look at here that the first is that of a straight chain alkane, means that look at here there are 5 contact points. So here the contact points are greater in number in case of a pentane because it is a straight chain alkane, which result in a greater chances of London dispersion forces. Now look at here a branch chain alkane, which is a neopentane. Here we have only 2 contact points. So this result in weaker London dispersion forces. So it's clear from here that an atom or molecule which having a greater surface area result in a stronger London dispersion forces. Now friends, I am going to ask a question from you. Which one of these having the greatest London dispersion forces? These are the noble gases: helium, neon, argon and krypton. Now look at here that the helium having 2 electrons, neon having 10 electrons, argon having 18 electrons and the krypton having 36 electrons. Now tell me that which one having stronger or greater London dispersion forces? As we have already learned that greater the number of electrons, stronger will be the London dispersion forces. So here the krypton having 36 electrons means that it having a greater London dispersion forces. Now friends, it's our time to take test. Now tell me which halogen having greatest London dispersion forces? Fluorine, chlorine, bromine or iodine? Now look at here that the fluorine molecule having 18 electrons, chlorine molecule having 34 electrons, bromine 70 electrons and the iodine having 106 electrons. So we know that the greater the number of electrons, stronger will be the London dispersion forces. Here we can say that the iodine having the greatest number of electrons, that are 106 electrons. Wow! So it must have a stronger London dispersion forces here. Friends, if you like this video, then don't forget to like, share and subscribe Digital Chemistry. Thanks for watching.